Okay, so now we're still in section 4.6 where I'm looking at the graphs of the other trig functions. The other trig functions are cotangent of x, cosecant of x, and secant of x. The idea is once I know what sine of x, cosine of x, and tangent of x look like, I understand that cotangent of x is 1 over tangent of x. So 1 over tangent of x. These dotted lines are tangent of x, right? So 1 over tangent of x, I'm going to have my asymptotes now from minus pi to 0, then to pi, and then to 2 pi, etc. So my asymptotes for cotangent are not at intervals of pi over 2, like they were for tangent, but at pi, right? Because the tangent of pi over 2 is undefined, so 1 over that would be an asymptote. I'm sorry, the tangent of pi is sine of pi over cosine of pi, so it's 0. Tangent of pi is 0, so tangent minus pi is 0, so 1 over 0 is undefined. So those are my asymptotes, minus pi, 0, pi, etc. And so cotangent will look like this, where I have 1 and minus 1 on the y, just flipped like this. Now, cosecant x is 1 over sine x. So I'm going to draw in sine x, my dotted line here, and 1 over that. So cosecant of x will look like this, and it will have vertical asymptotes at multiples of pi as well. Secant of x is 1 over cosine x. So I'm going to draw in cosine of x, and it will have vertical asymptotes at pi over 2, 3 pi over 2, right, minus pi over 2, minus 3 pi over 2, etc. Okay, and it will look like this. 1 over sine. Just to think about what 1 over cosine looks like for secant and what 1 over sine would look like for cosecant. Okay? So then I want to use the sine curve to obtain variations on the cosecant curve and use the cosine curve to obtain variations on the secant curve. Okay? The variations on the cotangent curve are going to be very similar to what we did with tangent, except that bx minus c will be 0 on the right side, on the left side for the vertical asymptote, and bx minus c will be pi on the right side. Right? Tangent was minus pi over 2 and pi over 2, so cotangent is 0 and pi. Set those equal to 0 and pi, solve for x, and that tells you what the vertical asymptotes are for I have a variation. And then the y-coordinate is a on the left side now and minus a on the right side, where for tangent it was flipped. Okay, so for example, if I want to graph y equals cotangent of pi over x, okay, so I set pi over x equal to 0, that tells me x equals 0. I set pi over x equal to pi on the right, that tells me x equals 1. So my vertical asymptotes are at multiples of 0, 1, 2, etc. I want to graph it between minus 2 and 2. There's no a here, so it's just 1. All right, so then 1, that would mean my cotangent looks like this between 0 and pi with the value on the left quarter there to be in 1 and the right quarter of that to be in minus 1, and then it repeats itself. So they're pretty simple once you get the idea. Secant of 2 over x, that's going to look like, now that's the secant of the absolute value of 2 over x, but let's look at just the secant of let's think of it as y equals, we want to look at 1 over cosine, right? So I'm going to draw in cosine. All right, I'm going to draw in cosine. Now, since this is an even function, the absolute value doesn't matter, right? Do you remember that? Cosine of minus x equals a cosine of x. So putting these absolute value signs in here for secant is somewhat tricky because it doesn't matter, right? It's an even function. So because the secant of minus 2x is equal to the secant of 2x. So I don't need to actually worry about these absolute value signs. So first of all, I draw in cosine, my little dotted line, right? Now, what do I need to do? I need to figure out what my variation of that would be. So cosine of 2x, its amplitude is 1, so I'm just drawing that in. And the period is going to be, move this over a little bit. The period is going to be 2 pi over b, which is pi. So notice I drew a cosine of a period of pi now instead of a period of 2 pi. And there is no phase shift here because there's no c, right? It's not bx minus c. So there's no phase shift. So I just draw in that cosine, and then I realize that secant is 1 over that, and then it's easy to draw these in, right? 1 over the 1 is 1. And then as I get closer and closer to 0, 1 over 0, that's getting closer and closer to minus infinity. Same way over here. 1 over 1 is 1, and then 1 over 0 is getting closer and closer to infinity, 1 over 0 is getting closer and closer to infinity, etc. Okay, so again, if you understand cosine and sine, then that makes you understand how variations of secant and cosecant work. And here's an example of, okay, absolute value of cosecant of 1/2 x. So let's first of all think about what sine of 1/2 x would look like, right? So the sine of 1/2 x, again, the amplitude is 1. The period is 2 pi over b, so 2 pi over a half is 4 pi. And again, there's no phase shift. So I'm going to draw in the sine function, but its period is 4 pi. So it's going to start at 0, come up to 1 at pi, down to 0 at 2 pi, down to 1 at minus pi, back to 0 at minus 2 pi. And it would repeat itself there. But now I want the absolute value of the cosecant. So if I just drew in the cosecant of 1/2 x, up here it would be this guy. And then on the other side where sine is negative, it would be down here. But since I want the absolute value of it, that now puts it up here.